In today's lesson, we're going to be looking at the area and perimeter of composite figures. And a composite figure is different from your normal shapes. It's basically a combination of shapes, or it could be a subtraction of shapes. But basically it is any form of all the kind of your regular rectangles, parallelograms, triangles, circles, semicircles, either added or subtracted together to form one single figure. So if we look at the example off to our right, we can see this shape over here. That's an example of a composite figure. So looking at it, hopefully we can kind of identify some of the similar or regular shapes that we're used to. So what we're going to do first is find the area of this shape. And the way we find the area of a composite shape is we break it down into the shapes that we know. So you can do this basically on the diagram as well, or you can separate them off to the side. And there's usually multiple ways to do this. Right? We do see that we do have a triangle here, so I'm going to draw a line straight down so that I form this triangle. And now in the other side, you have two options. You can either form a long rectangle like that and a smaller one, or you can form one like this. Again, it's all based on what information is given to you. Maybe you have little or fewer calculations depending on which way you decide to do it, but in the end it should be the same. So I'm just going to draw it like this to draw out my two shapes. So we'll label them 1, 2, and 3. Before I start finding the area though, I need to find some missing lengths. So in my third shape up here, again we know that this should be 5 inches because the distance across is the same as the one on the top. For this shape in number 2, the entire thing is 15 inches, but I know from one end to where the triangle starts, it's 5 inches plus 7 inches. So this is 12 inches here. And then over here in my triangle, this last part is 3 inches. As well, for the height of the triangle, I am missing that, but I know that my full length from here to here has to be 10 inches. If I know from here to here is 6, then that remaining part has to be 4. So this actual height over here is 4 inches. That's 6, and from there it's 4. So now I have all my sides labeled. I have enough information to go work through finding the area. So the area of my triangle is 1/2 base times height. So in this case, 1/2 times, and actually let's just draw it with our key information. So it was 3 inches and 4 inches. So 1/2, 3 times 4, which works out to 6 inches squared. If I look at the area of my long rectangle, or the number 2 shape, actually let's move this down so I can draw it a bit, just separately. Again, we know that the one length was 5 or 4, the other one was 12. The area of a rectangle formula is length times width. So in this case, 4 times 12, which equals 48 inches squared. And then in our third shape, the smaller rectangle, again, it's length times width. If I just draw it out just to get my measurements again, it was 5 by 6. So 5 times 6, or 30 inches squared. So once I found the areas of all my 3 pieces, to find my total area of the entire shape, I just need to add all of them up. So the area of the triangle plus the area of the rectangle plus the area of the other rectangle, all added up is going to be the area of my entire, or my composite figure. So I have 6 plus 48 plus 30 gives me a total area of 84 inches squared. And that's the area of this composite figure. B is asking me to find the perimeter. Again, the perimeter is the distance around the object. So when we have composite figures, it's only the distance around. It's never anything in the middle, unless we're talking about fencing and it's talking specifically about fences going up and down the middle. But in this case, it is just the distance around our object. So I'm just going to roughly go through and just highlight all those sides, just as a reference so we're aware of what we're actually looking for. So those are all the side lengths I need to know, and I'm going to add them all up to find out what the sum is. So the perimeter, the formula is basically side 1 plus side 2 plus side 3. We have 1, 2, 3, 4, 5, 6. Plus, then we'll go on to plus side 6. So I need to know all of my side lengths in order to add them up. However, looking at this shape, there's only one side length I don't know. And that one is this one here. I don't know what this side length is. And there's a couple ways we could look at it. One, the line tells me that it should be parallel with this, or the same as this 5-inch one. Another option is, if I'm unsure, remember we did draw in lines in our last one. We knew this was 4 and we knew this was 3. I could find that length using Pythagorean theorem. A squared plus b squared equals c squared. 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 equals c squared. Or the square root of 25 equals c. Or 5 equals c. So regardless of which way you want to figure it out, you understanding that the straight line means that these two are the same, or by using Pythagorean theorem, by reasoning through the heights or the sides of this triangle, you could find it either way. In some cases, you may have to use Pythagorean theorem because they don't give you enough information, or they don't tell you that it's the same length. In other cases, you may not have to. But just be aware that there is that option available. So we're going to add up all our sides. It may help to pick a starting point and then just go around the object, writing down all the sides. That way you don't worry about forgetting a side or mixing one up. So I'm going to start at the top with 5 inches. So 5, and I'm going to go, say, clockwise. So 5 plus 10 plus 15 plus 5 plus 7 plus 6, and then I'm back to the beginning. So that's all those are all my sides. And again, this just is adding them all up. 5 plus 10 plus 15 plus 5 plus 7 plus 6 equals 48 inches. So the perimeter of this object, or this composite figure, is 48 inches. Example 2 is looking at a hotel entrance. A hotel is remodeling its outdoor entrance. The new design is a tile walkway leading to a semicircular fountain. The first thing I want to do is find the area. So I have my diagram here. I can see this one's a little different because it's not shapes added together, it's actually shapes subtracted from each other. And we see that it's a normal rectangle, except we've taken out this semicircle here. Right, so that semicircle, or that part of the rectangle that's normally there, is actually taken out. So in this case, whenever you have something that looks like this, you actually have to subtract your areas. So what we want to do is we want to find the area of the large general shape and subtract whatever's removed. So in this case, I'm going to need to find the area of my rectangle. And if I look at that rectangle separately, we know that the one length is 5.2, the other one is 2.1. The area of a rectangle is length times width again. So 2.1 times 5.2 gives us an area of 10.92 meters squared. The next thing I need to do is find the area of my semicircle. And a semicircle is just half of a circle. So I can take the area formula for a circle, pi r squared, and divide that by 2 to get the area of my semicircle. Because our formula is dealing with, or of a circle is dealing with the radius, remember that the radius is from the center out. Or basically half my diameter. And the diameter is the entire distance across. So if I know my diameter, the entire distance across from the circle has to match that one length of my rectangle, my radius is equal to 2.1 divided by 2. Or 1.05 meters. So I know my radius now, so now I can figure out the area of this shape. So pi, or 3.14. It is a button on your calculator, but you can also use 3.14 as well if you prefer. The only difference is you may get a slightly different rounding at the end. So 3.14 times 1.05 squared, all divided by 2. So we should get, again, I'm just going to break it down into a few more steps just so that if you're when you're following along, you can kind of double check your calculations. So 3.46 divided by 2, you get 1.73 meters squared. So that's the area that this semicircle represents. So to figure out the area of the entire thing, I need to take the area of my large shape, or the area of the rectangle, and subtract the area of my semicircle. So 10.92 meters squared minus 1.73 meters squared equals 10.92 minus 1.73 works out to 9.19 meters squared. So the area of that walkway is 1.19 meters squared. The second part is finding the perimeter. Again, it's going to be the same idea. I need to find all my lengths. So because it's a rectangle, I know that the opposite side of this is the same. I just need to find the length of this curve, or basically half the circumference of a circle. And remember, the circumference just means the perimeter of a circle. I have half a circle here, so I just need to find the circumference of the entire circle and divide it by 2. So the circumference is equal to pi times d, or the diameter. Again, remember, because it is a semicircle formed from that rectangle, that diameter is 2.1 meters. So we get 3.14 times 2.1 which equals 6.594. But to find that distance, I need to divide it by 2. So 6.594 divided by 2, 3.297, or we'll say 3.3. So this distance here, or this length of this curve, is 3.3. Now that I have all of that information, I can find the perimeter because it's just side 1 plus side 2 plus side 3 plus side 4. So 5.2, again, I'm just going to pick one side to start with and work my way around. 5.2 plus 2.1 plus 5.2 again plus 3.3. Add them all up, and we should get a perimeter of 15.8 meters. So again, those are just two examples of looking at composite shapes and finding the area and the perimeter. You may have multiple different types, again, depending on what shapes you're adding together or subtracting, but the main idea is you have to find the area of the individual shapes. You may have to subtract them in some cases. You may have to add them, and same with perimeter. You may have to do some work to find some of the side lengths, especially those of, say, circles or sometimes triangles. You may have to use Pythagorean theorem. So again, break it down into the shapes that you're familiar with. So those squares, rectangles, triangles, and circles. And then from there, reason through what you have to do to find the area and the perimeter.